Homework 11, Section 6.1, Discrete Random Variables, Video 5. Using a distribution to make an inference about a population. So why are we talking about probabilities when this is class of statistics? As I mentioned before, part of statistics is making an inference about a population based on what you get from a sample. So for example, let's take a look at this example, which is on page 257. An airport facility has the following spaces. We'll look at it in a moment. Let x equal the hourly parking fee for a space. Create a distribution for x. There are 4 types of spaces: covered long-term, covered short-term, uncovered long-term, uncovered short-term. The cost for these spaces on an hourly rate is $2, $4.50, $1.50, and $4 respectively. And the number of spaces that they have for each type is 142, 378, 423, and 57 for a total of 1,000 spaces. If we want to create a distribution for x, which is the hourly parking fee for a space, all we have to do is set up a 2-column table, one column for x and the other for the probability of x. Under the first column, list all the possible values of x. Well, if x is the hourly parking fee for a space, these are the values of x. X can equal $2, $4.50, $1.50, or $4. But how would we calculate the probability of each of these hourly fees occurring? Well, assuming that all of the spaces are equally likely, and I don't think it actually said that in the particular problem, but we're working on the assumption. If we picked a space at random, what's the probability we would pick a $2 per hour space? It's pretty easy. Out of the 1,000 spaces, 142 of them are $2 per hour. That's easy to turn into a decimal, 0.142. And the same thing for the rest of them. There are 378 spaces where x equals $4.50. So the probability that x equals $4.50 is 378 out of 1,000, or 0.378. For $1.50, there were 423 such spaces. So the probability is 423 out of 1,000, or 0.423. And then for the $4 an hour space, there were only 57 of them out of 1,000 spaces. So the probability is 0.057. So some probability distributions you can create because you already know how many times each particular value can occur and the total number of outcomes. So you're just setting up your fractions to create your probabilities. Similar to what we did when we rolled the dice, we just counted out of the 36 sums how many of them were certain values. Out of the 1,000 spaces, how many of them invoke a certain hourly rate. In the next video, we're going to do another follow-up question with this particular distribution.